In this video, we're going to discuss the multiplication rule for probability. This is similar to the addition rule for probability that we already covered, and there will be two versions. There will be the first version we see here, and then there will be a general multiplication rule. However, the general multiplication rule gets a bit more complicated, and I'm saving that for a separate video. So let's just go over this one. In the addition rule video, you remember we had disjoint events, and the first rule worked only for those events. Similarly, we're going to have something here called independent events, and this rule will only work for independent events. So let's go ahead and say what they mean. So events E and F are independent if one event being true does not change the probability of the other event being true. A classic example here, if I flip a coin and I get a heads, and then I flip it a second time and I get a tails, the fact that I got a heads on the first flip does not affect the probability that I'm going to get a tails on the second flip. So that means the event E being getting a heads on the first flip and the event F being getting a tails on the second flip, those two are independent. I could say event E is, I'm going to roll a dice here, and E is I get a 1, and then I'm going to flip a coin, and F is I'm going to get a heads. Well, the fact that I got a 1 on my dice roll is not going to affect whether I get a heads on the coin flip. They're completely separate. They don't affect each other here. Now, let me give an example of things that are not independent. If I flip a coin and E is the event that my first flip is a heads, and F is the event where my first flip is a tails. So in this case, E is your first flip is a head, F is your first flip is a tail. Well, since it's the first flip, if I know I got a heads, then the probability of getting a tails goes to 0%. It couldn't have happened. So in that case, those events are not independent because if one of them is true, the other one automatically has a 0% chance of happening. So independent events, sometimes they're kind of easy to say, well, of course, this thing's not going to have any effect on that thing, and you can say they're independent. Other times, it is much more complicated. For example, if I were to draw a card randomly out of a deck of cards, and I got an ace of spades, and then I was to draw a second card, and the second card, I want to see whether it's going to be an ace of clubs or not. Well, maybe that's independent of getting the first ace, maybe it's not independent. So sometimes it's a lot more difficult, and we will have examples later on where we try to see whether things are independent or not. But for right now, if they're independent, we can then give the multiplication rule. So if E and F are independent, then the probability that they are both going to happen, E and F, is just going to equal the probability of E times the probability of F. So again, if you have events that are independent and you want to find the probability of them both happening, you just have to multiply the two individual probabilities. And in fact, this can be extended if you want to have 3 or 4 or 5. So let's say E, F, and G are independent. And you want to find the probability of E and F and G. Well, again, you just multiply them all together here. So whenever you have independent events, it's pretty straightforward to calculate the probability of all of them happening at the same time. Of course, in order to do that, you have to know they're independent. Some problems, they will tell you they're independent. Some problems, you have to think about it and decide for yourself if they're independent. And some problems, we're going to see a calculation method later on to determine whether things are independent or not. Now what we're going to do is we're going to use the multiplication rule as well as the complement rule from before to find this following probability. So let me remind you of the complement rule from the previous video. And there was two ways of writing it. I'm going to write it where it says the probability of the event we're looking for is 1 minus the probability of the complement of that event. So if you read this problem here, it says if there's a 30% chance that you will win a game and you play the game 5 times, what is the probability that you will win at least once? Well, first off, I am going to have to assume that each time you play the game, the results are independent. Right, we already said that the only way to use the multiplication rule in this video is if we have independent events, so they better be independent. And if you think about it, most games you play, let's say blackjack or poker or so on, whether you win one particular hand is not going to affect whether you win the next hand and so on. It's a new deck of cards, a new deal, and everything there. So assuming that they're independent is usually not too bad of an assumption in these types of problems. However, if you read the problem the way it's written, it's actually going to be pretty complicated. So E is we're going to win at least once in 5 games. If you wanted to try to write that out as an event with all the outcomes, well, you could win and then lose 4 times. You could lose, win, and then lose 3 times. And you'd have some more where you won exactly 1 time. And then you might win 2 times. But those 2 times could happen the first or in the second or the first and the third. And you would have this big, long mess of all these possible ways where you could win at least 1 time. And that would be very complicated to get the answer. However, if we look at the complement, what would it mean that I did not win at least 1 time? Well, the opposite of winning at least once means you never won at all. And guess what? There's only one situation where that happens. Lose, 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 lose. That's the only situation where you are going to not win at all. And so what I can then do is I can say the probability of losing 5 times in a row, which is the same as the probability of E complement. That's the probability of losing on the first time times probability of losing the second time times probability of losing a third time, 4th time, and 5th time. And the reason why I can just multiply them all individually, this is exactly the multiplication rule, where instead of having 3 things, I have 5 things. But again, I'm assuming that each one, whether I win or lose, is independent. So now what's the probability of lose? At first guess, you might say, well, let's put 30% here. But we have to be careful. It's a 30% chance that you will win. 30% chance you will win. So that means there's a 70% chance you will lose. And if we go ahead and put this in our calculator, 0.7 times itself 5 times. Or you can even use exponents here, 0.7 to the 5th. I am getting 0.16807. And what that means is, using the complement rule, the probability that we win at least once is going to be 1 minus this number we just calculated. And putting that in my calculator, I get 83,193, or if I round it, say 83.2%. So this is the chance that you'd win at least once in those 5 games, when there's a 30% chance in each one of them that you would win. Again, I wanted to really show you how the complement rule can come into play, even when the problem has nothing to do with complements originally, as well as how we can then use the multiplication rule for independent events to get a probability here.